PV solar panel explained. Types. Construction. Defects. A tiny crack. Big consequences. Many people see a solar panel as just a sheet of glass. But inside, it has carefully engineered components working together to convert sunlight into electricity. Understanding how a PV panel is built and how defects develop is essential for anyone involved in solar energy. In this video, you'll learn the different types of PV panels, how they are constructed, their key components, and why using damaged panels can seriously affect the performance of a solar power system. Welcome to Gab Tech Insights. What is a PV solar panel? A photovoltaic, or PV solar panel is a device that converts sunlight directly into electrical energy through the photovoltaic effect. When sunlight strikes the solar cells, electrons are energized, producing direct current, or DC electricity. This electricity is then combined with other panels in a solar array and converted into usable AC power through an inverter. PV panels are the heart of every solar power system, from small rooftop installations to large utility-scale solar farms. Types of PV solar panels. There are three major types of PV panels. Monocrystalline panels. These panels are made from a single crystal of silicon. They offer the highest efficiency, perform well in low light conditions, occupy less installation space, and typically have the longest lifespan. Their main disadvantage is their higher purchase cost. Polycrystalline panels. These panels are manufactured using multiple silicon crystal fragments. They are more affordable and easier to produce, but generally have lower efficiency and require more installation space than monocrystalline panels. Thin film panels. Thin film panels are produced by depositing photovoltaic materials onto a thin substrate. They are lightweight, flexible, and suitable for specialized applications such as curved roofs or portable systems. However, they have lower efficiency and require a larger surface area to produce the same amount of electricity. How a PV panel is constructed. A solar panel is made of several protective layers that work together to ensure efficient electricity generation and long-term durability. At the top is tempered glass, which protects the panel from rain, hail, dust, and mechanical impacts while allowing sunlight to pass through. Beneath the glass is the EVA encapsulant layer. This transparent material cushions and seals the solar cells against moisture and vibration. The solar cells form the core of the panel. These silicon cells convert sunlight into electrical energy. Below the cells is another EVA layer, followed by the backsheet, which provides electrical insulation and protects the panel from environmental damage. The entire assembly is enclosed within a strong aluminum frame for mechanical support. At the rear of the panel is the junction box, which houses the electrical connections and bypass diodes that help reduce power losses caused by partial shading. Main components of PV panel includes tempered glass, EVA encapsulant, silicon cells, backsheet, aluminium frame, junction box, bypass diodes, output cables and MC4. Each component performs a specific function. If even one component fails, the overall performance of the panel can be significantly affected. Common causes of PV panel defects. Although PV panels are designed to withstand harsh outdoor conditions, they can still develop defects over time. Physical impacts from transportation, falling objects, hailstorms, or improper handling may crack the glass or damage internal cells. Microcracks are tiny fractures inside the solar cells. They are often invisible but gradually reduce energy production. Delamination occurs when the protective layers separate because of poor manufacturing, aging, or prolonged heat exposure. Moisture ingress happens when damaged seals allow water to enter the panel, leading to corrosion and electrical failure. Hotspots develop when part of a panel overheats due to shading, dirt accumulation, damaged cells, or poor electrical connections. Potential induced degradation, commonly known as PID, causes electrical leakage that reduces panel efficiency over time. Long-term exposure to ultraviolet radiation and harsh weather conditions can also weaken panel materials and accelerate aging. Consequences of using damaged PV panels. Using damaged solar panels can have serious technical and financial consequences. Power generation decreases because defective cells cannot convert sunlight efficiently. Hotspots may develop, creating localized overheating that can damage surrounding components and increase fire risk. Damaged panels may trigger inverter alarms, reduce string performance, and lower the overall output of the entire solar array. Maintenance costs increase because technicians spend more time troubleshooting and replacing faulty modules. Reduced energy production means lower revenue and a longer return on investment for commercial solar plants. Ignoring damaged panels can eventually shorten the lifespan of the entire solar installation. Practical tips. Always inspect PV panels during routine maintenance. Look for cracked glass, discoloration, delamination, burn marks, corrosion, loose connectors, or damaged junction boxes. Clean panels regularly using recommended methods to remove dust and bird droppings. Use thermal imaging and electrical testing to identify hidden defects before they become major failures. Replace severely damaged panels as soon as possible to maintain system efficiency and safety. Remember, preventive maintenance is always more cost-effective than corrective repairs. PV solar panels are remarkable engineering devices that convert sunlight into clean, renewable electricity. Understanding their types, construction, components, and common defects helps engineers, technicians, and installers maximize system performance while reducing maintenance costs and improving safety. A well-maintained solar panel delivers reliable energy for decades, but a neglected or damaged panel can reduce the performance of an entire solar power system. If you found this video informative, please give it a thumbs up, subscribe to GabTech Insights, and turn on the notification bell so you never miss our latest engineering and renewable energy content. If you have any questions or topics you'd like us to cover next, leave them in the comment section. Thank you for watching, and I'll see you in the next video.